So in this video, we are going to discuss about how to do statistical analysis on top of Numpy arrays. We are going to calculate the mean, medians, standard deviation, min and max values of the Numpy arrays, correlation between two Numpy arrays, and we are going to do some more analysis like how many elements are there in a Numpy array which are repeated and what is their counts. So let's import the Numpy array first. Now we are going to define an array so let's say the array is 1 2 3 4. Okay, now let's see how to compute the mean of a Numpy array. So we'll simply do print np dot mean a. So you can see if you take the sum of all these four elements 1 2 3 4, the sum will come out as 10 and its mean will be 10 divided by 4 since there are 4 elements, so it will be 2.5. So to compute the mean of a Numpy array, you can simply do np dot mean of that Numpy array. Now we are going to see how to compute the mean on multi-dimensional arrays. So now we will see how to compute the mean on multi-dimensional Numpy arrays. So let's first define a multi-dimensional Numpy array. So this is our multi-dimensional Numpy array of size 3, 3, that is 3 rows and 3 columns. Now let's compute the mean of this multi-dimensional Numpy array. Okay, so see, this is the 3 cross 3 array, and when we simply passed b to this function np.mean, it took the sum of all the elements and then divided by the number of elements and got this as the value. Okay, so this is one way of taking the mean. Now let's say you want to take mean along the row or along the column of this multi-dimensional array. So how you can do it? If you remember from my previous lectures, we can pass an argument called x is equal to 0 and x is equal to 1 to play around with rows and columns. So the same thing we can do. We can have np mean calculated along x is equal to 0. That means along column. So let's see, 5 plus 4 plus 1, that is 10. Okay, 10 divided by 3, that is 3.33. okay, so if you pass x is equal to 0, it will compute the mean along the columns. Similarly, if you pass x is equal to 1, it will compute the mean along the row. So along the row, 1 plus 6 is 7, plus 7, that is 14, 14 divided by 3, that is 4.666. okay, similarly here 8 plus 4 12 plus 6 18 divided by 3, that is 6. So if you want to compute the mean of a multidimensional array along the row, you can pass x is equal to 1. If you want to compute the mean along the column, you can say x is equal to 0. So now just like we computed the mean of a Numpy array, we can also compute the medians of the Numpy arrays. The format will be same, just the only difference will be instead of the function np.mean, we are going to use the function np.median. That's going to be the only difference. So let me quickly show you how to do that. np.median. So this is the median of the whole two-dimensional array. Here also you can use x is equal to 0 and x is equal to 1, just like you have used in mean to compute mean along the row and column. Similarly, you can compute median along the row and column by using the access format. Right, you can do x is equal to 1 also. Cool. So that's all. That's how you are going to compute the median of a Numpy array. So just like mean and median, You can also compute the minimum and maximum values of numpy arrays using the function max and min. And here also you can apply the x is equal to 0, x is equal to 1, or not passing any axis at all. Okay, so there are 3 different ways you can compute the min and max values. I'm not going to explain how to do the min. You can just simply replace np.max with np.min and you will be able to do all the minimum computations just like maximum computation. So similarly, you can do the standard deviation computations for numpy arrays also. You can use x is equal to 0, x is equal to 1, or not passing any axis at all. If you are not passing any axis at all, it means you are trying to compute the standard deviation of all the elements of the multidimensional numpy array. Right? To compute correlation of 2 numpy arrays, there is a simple function called np.correlate. You pass both the numpy arrays to it and it will compute the correlation between those 2 numpy arrays for you. Now, let's say we have a numpy array given to us and we want to find all the unique elements in that numpy array. So you can see in this array 2 is repeated 2 times, 3 is repeated 2 times, rest of the elements are not repeated at all. Now to get the count of each and every unique element in this numpy array, how we can do it? There is a very simple np.unique function to solve this problem exactly. So we are going to do np.unique d and it will first find all the unique elements from the above array. So you can see all the repeated elements are not available in this unique array. Now if you also want to get the count of each and every element, okay, how you can do it? You need to pass an extra argument here which says return counts equal to true. If you pass this extra argument to this unique function, it will give you the count of each and every element. Okay, so you can say 1, since it has not been repeated, so it has been given as it is repeated once only. 2, it has come twice. 3 also has come twice. 4 and 5, since they have not been repeated, they have been shown as repetition count as 1, 1. Okay, so just by passing this additional parameter, you can identify the number of times some element has been repeated